Someone have sent me an email and he wants me to show the time expression of the currents that are interning and leaving a node in an electrical circuit. And this is the node, the current I1 is interning the node, I2, I3 are leaving. And we have the phasor expression for current 1, and we already have the time expression for current 2, and we need to also find this current. So since he's asking for the time expression of all the currents, so let's find the time expression for this for the current 1. So the phasor expression, we can write this phasor expression as 3 squared plus 4 squared to power 1/2 e to power j tangent inverse of -4 divided by 3. So this will be equal to 9 plus 16, square root of that will be 5 e to power j tangent inverse of 4 divided by 3, -4 divided by 3. So -4 divided by 3, inverse tangent of that is 53 degrees. So it will be -53 degrees. So this is the exponential form, phasor form, at the time expression for I1. The time expression for I1 will be equal to 5 times cosine of omega t minus 53 degrees. So this is the time expression for I1. And now we already have the time expression for I2. So let's find I3. So in order to find I3, we know that the currents interning a node will be negative, and leaving the node will be positive, and the summation of the current that intern and leave must be equal to 0. So we can write minus I1 plus I2 plus I3 must be equal to 0. We can also write this in a phasor form as minus I1 plus I2 plus I3 is equal to 0. So from here we can find the current I3 in a phasor form will be equal to I1 minus I2. And we know that in addition and subtraction, the rectangular form is the best way. So we already have the rectangular form for I1. So now with the time expression for I2, we can find the rectangular form also for I2. So this I2 in time expression, we can write this as we can write I2 in a phasor expression as 2 e to power j minus 90 degrees. Now we can use the Euler formula, which is e to power j theta is equal to cosine of theta plus j sine of theta. So by using that formula, we can write this as 2 multiplied by the cosine of minus 90 degree plus j sine of minus 90 degree. And we know that the cosine of minus 90 degree will be 0, and the sine of minus 90 degree will be -1. So this will be equal to minus J2. So minus J2 is the phasor expression for the I2. So now that we have both phasor expression for I1 and I2, we can find I3. I3 is equal to I1, which is 3 minus J4 minus I2 minus J2. So minus and minus will be plus, so will be equal to 3 minus J2. So this is the phasor form of I3 in rectangular form. Now we can also write that in exponential form as I3 is equal to 3 squared plus 2 squared to power 1/2 e to power j tangent inverse of -2 divided by 3. So this will be equal to 9 plus 4, which is 13, the square root of 13, e to power j, and minus tangent inverse of -2/3, -2 divided by 3 is equal to that. Tangent inverse of that will be 33.7 degree, minus 33.7 degree. Now that we have that in an exponential form, we can write the time expression for I3 will be equal to the square root of 13 cosine of omega t minus 33.7 degree. So that is also the time expression for the I3. In this type of problems, you have to be careful when you're converting from rectangular form, from a phasor form, rectangular to exponential, and then to the time expression. Otherwise, once you solve a few more problems, you will get used to it. I hope you like it.